Hi, everyone. So we're getting ready for the chapter or unit 2 test, right? So if we take a look at this, this is going to be the packet that you can find in your Canvas on the Canvas page. Just look on today's date and you will be able to find it. So here it says determine if the sequence is arithmetic. Okay, obviously it's arithmetic because all of these are arithmetic. But the way you would check that and the way I would check that, because if you had a sequence and you're like, I don't know, is it arithmetic, geometric? So what I would do is I would just be like, okay, first thing I'm always try add and subtract, right? And it looks like they're increasing by the same amount of like 3 plus 13, 3 plus 13, 3 plus 10 would give me 13, right? And then 13 plus 23 gives me, I keep on doing it, 13 plus 10 gives me 23. So same thing. So, or you can just subtract these two guys, right? 13 minus 3, that would give you 10. So since we're getting bigger, we're adding 10, right? If we were getting smaller, then we would subtract 10. And again, just like this, yep, 23 plus 10. So if you have a number, try it for the other and see if it works. Okay, that's what I would do. And then remember, this is the common difference. So that is going to be D is equal to 10. And if they ask you, oh, what's the explicit formula? You're like, oh, I know how to do that. So this is what I would suggest you do. Okay, write this on a sheet of paper, like your notes. I would call it your page of notes, right? You don't have to make a page of notes, but it's always, it's much easier to refer to instead of trying to look through your book. Book's kind of look a lot bigger than like a page of notes, right? And also making a page of notes is helpful for your to study, to memorize things, right? To remember things. So explicit formula, and then we have a recursive formula. So if I can spell formula, apparently I can't. Okay, so explicit, there are only two things you need to change. Recursive, there's only one thing you need to change. Everything else that is not highlighted is going to stay the same. Okay, so for explicit formula, remember this is a sub n, which means this is any term. It doesn't matter what term it is. That's why it's called the formula, because it could figure out any term. You say, oh, I want the 48th term, then n would be 48. If I want the 101st term, then this would be 101, right? That because that just indicates what term it's at. That's all. And then we're going to take the first term. This is going to be the first term, and we're going to add it to whatever the difference is, common difference. And then we're going to remember, because this is just repeated adding, right? Whenever we do repeated adding, that's actually multiplication, right? So this is what we're going to do. And what we change is just this, just the A, the first term, and the D. The A sub n and the n minus 1, that will always stay the same for the formula. We would only need it, we only plug things in there if we're trying to find a specific term. That's it. Okay. So let's take a look here. This one right here. Recursive formula is going to be similar, but it's a little bit more simple. So to get whatever term, and it's A for arithmetic for in this case, and we're going to, we don't even need the first term, we're just going to take the previous term. So it's going to be, excuse me, it's going to be A sub n minus 1, right? That was that previous term. Whatever n was is minus 1 to it, right? And then we're going to add the difference, right? Like here, we would add 10. Okay, so the only thing that would change is this. Everything else stays the same. So we're going to use this the whole time here for these 4 problems, right? And my recommendation is that you do them by yourself first and then check. Or you can watch through one problem, go through it together, and then pause it, and then we'll go through the other ones, okay? That's what I would do, and just like fast forward. You don't need to spend the whole time doing it unless you want to. I will not stop you, right? Or you can just put it on repeat. Just keep on hearing it. All right, so here we go. So that's the difference is that, and then the explicit formula. Here we go, explicit. What is the explicit formula? Okay, well, this is not highlighted, so it's going to be A sub n is equal to my first term. And what in the world is my first term? This guy right there, right? That's my first term. Always, it's the first number, right? The first term. So that's going to be 3 plus my D, which is 10, n minus 1. There we go. Done. Nothing else to do. This is it. Do you see how like there's no work to be shown? You just either have it or you don't. And recursive is going to be, again, we're going to copy everything else down except for what is highlighted because we're going to replace that with a number. So a sub n is equal to a sub n minus 1, so that previous term, and we're going to add 10 to it. So that's how we've been getting, right? So what would be the next three terms? Well, you're like, okay, well, it's the previous term plus 10, so that's going to be 43, 53, 63. If you really wanted to, so this is the 1, 2, 3, 4, 5, 6. This is the 7th term right here, right? So what we could do, just to show you that this works, so we could use the explicit formula, right? You don't need to do this on the test, but I'm just showing you how it works. So a sub 7, right, is equal to 3 plus 10. And remember, we substituted a 7 for n. So this is going to be 7 minus 1, just like that. All right, and then it's going to be order of operations. So it's parentheses first. So 3 plus 10 times 6. And because 7 minus 1 is 6. And then we're going to multiply first because that's order of operations, right? So that's going to be is equal to 3 plus 60, and that would be 63. And if you notice, what? That's the same thing. See? So we could use this. This is useful, not for like these ones that are pretty close by, where it's just easier just to add 10 to get to the 7th term. But if I ask you for, oh, well, what about the 80th term? What is that going to be? I am not going to go do this 80 times, right? So I would just plug it into the equation. That would be a lot easier to do. So I would just use the explicit formula at that point. Okay. Righty. But that's how those formulas work. And here, if you take a look here, okay, we're definitely getting smaller. So we're going to be subtracting, right? So how much are we subtracting? Where it looks like we're subtracting by 10, right? Ooh, subtract 10. Just to make sure, yeah, -4 minus 10, -14. If you're not good with your negatives, put in the calculator, see if it works, right? Just make sure you put it in right. So our D is going to be -10, and our explicit, I'm just going to go exp, is going to be a sub n is equal to, remember my first term is 16 right there. So 16 plus, or plus negative, so I'm just going to go, so plus negative, which would just be minus 10 and minus 1. 10. Recursive. A sub n is equal to a sub n minus 1. And that's my plus d, so it should be minus 10. The reason why it's minus, because remember the plus the negative, it's the same thing as subtracting. And then the next three terms, I just like to do them like this. So we're going to get more negative, so that's going to be -24, -34, and -44. Right? We technically did that in class, so you should have known that one. Right? Again, pause, do number 3, and then watch it, see if you did it right. Right? And so if we look at this one right here, this is we're getting bigger, and we're getting bigger by 20. And if that one's hard to figure out, then you just do this one, because 8. How many do we need to add from 8 to get to add to 8 to get to 28? Plus 20, not hard, right? And it's true here as well, right? So our D is equal to 20. Is it always going to be like a factor of 10? No, it just happens to be. I don't know why I did them all like 10. I should have done one like 5 or 2. Darn it. Okay, anyways. So explicit is a sub n is equal to -12. That's our first term, plus 20 times n minus 1. And what is it called? Recursive is that whatever the term we want, and then do we get that by doing the previous term, a sub n minus 1 plus 20. Whatever the previous term is, we just add 20 to it to get to the next term. There we go. And the next three terms are going to be 68, 88, and 108, right? And here we have, looks like we're getting much lower, subtracting by 100, right? So when I'm subtracting 100, so our D is going to be common difference, -100, all right? And then our explicit, do you see how it's the exact same thing over and over again? It does not change. Yep. First term is going to be 1. Plus, not plus, it's minus because this is negative. So minus 100 times n minus 1. And our recursive is going to be a sub n is equal to our previous term minus 100. Right, and we're going to just continue. So negative 399, negative 499, negative 599. Hopefully this is not your bank account. This would be sad days. Okay, you need to put in some money in there. We need to get a job. All right, so that's how that works. That would be for arithmetic. Remember, that's just repeated addition. You start at a place, then it's repeated addition from that place. All right, and then so now we're going to go into geometric. So geometric is going to look like this. Remember, so from 1 to 2. So normally what I would do is, okay, remember I told you I would first see if I could add. So I'd be like, oh, this is like +1. This is +2. Ooh, these are two different numbers. So this is not arithmetic. I would erase that and go, okay, it's not plus. Is there another way to get to 2 from 1 to 2? Well, I could times it by 2, right? Times 2, and then 2 times 2. Oh, yeah. And then 4 times 2. Do you see how it's the same number every time? That's how we know it's geometric. And if it doesn't fit any of those patterns, like there's no consistent number that you're adding or multiplying, then it's neither arithmetic nor geometric, because you could have all sorts of sequences, but those are the two that we're focused on. So you're just like, neither, doesn't fit any of those patterns. Okay, so let's see here. We know it's geometric, find the common ratio. So R is equal to 2. It's the thing that we keep on multiplying. Now, right here. So this is the common, this is the formula that we would normally use. And then we just replace, again, two things, explicit formula and recursive formula. For recursive, it's only one thing that you need to replace, recursive formula. Formula. Okay, so this is going to be, now instead of A, we're going to use G. Technically, we can use any letter, but we're just going to say G for geometric, A for arithmetic, right? So G sub n is equal to the first term, right? Because that first term really matters, because that's our starting point, right? And then from there, we're going to keep on multiplying the same number, right? So here, G sub n times, remember, we're repeated multiplying, so times R to the n minus 1. Okay, so the only things that change is the G, because that first term, we need that first term, and the R. Everything else stays the same. It does not change, right? So recursive, again, is G sub n is equal to whatever that previous number is, and times that by R. That's it. So the only thing you would have to change for that is just this R. Everything else, you just copy that down. It's just the same thing. It's not different. So let's go explicit, recursive. And this one, we're actually going to try and use it. Use the formula for it. Here we go. So explicit is going to be, so for us is G sub n is equal to, what is it equal to? That first term, which is right here, 1, times R to the n minus 1. So we know our R is 2, so it's 2 to the n minus 1 power. Please make those small. Don't make them big. Don't be like, oh, to the n minus, no, bad. That's 2n minus 1, not 2 to the n minus 1. Different. Okay, and here we go. And then our recursive is going to be G sub n is going to be the previous term times 2. This 2 right here, 2. Done. All right, and then 3 terms. So remember, we're just multiplying by 2. So this is going to be 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, right? And here it says we want to find the 12th term. So I know it says A, but let's imagine that that's a G, okay? And yeah, because I told you can pick any letter, any variable, it doesn't matter. But in the book, they chose to use G instead just to make it less confusing. So it's going to be G sub n, sub 12, actually. So G sub 12. And the easier one to use is the explicit one, because I mean, unless you want to go 12, we can, but I think this is easier. So we're just going to plug this in. So 1 times 2 to the, says 12, so 12 minus 1. If you want to just put in there 11, you can totally do that as well, if you want that little shortcut. So that's going to be 1 times 2 to the 11. And you're going to take your calculator or Desmos on your phone. And we're going to go right here, 2. And then do you see this AB? a to the b power. There we go. And that's going to be 11. And if you see right here, ooh, 2048. I know that number. So the 12th term is 2048. You see how a lot easier that is, a lot less work than this, I think, my own personal experience. And that's this answer right there. So we're going to do the same thing here. Again, I know it's geometric right now, so I'm going to just try to find a number to multiply. But if I didn't, like it didn't say like it was geometric or arithmetic, then I would first try see if I could find the same number to add or subtract with. And if that doesn't work out, like how we did with number 5, that's what I would do. Then I would go to multiplication. Like, well, how do we get from 4 to -8? Oh, multiply by -2. So let's see if that works. If I multiply this by -2, so -8 times -2, yeah, that's positive 16. And positive 16 times -2 is going to be -32. So if you see numbers like going from positive to negative to positive to negative, you know a negative is involved. Something negative is going on. All right. So our R is going to be -2. My dear, I think I need some water. And then explicit formula and recursive formula. So explicit is going to be, so our first term right here is 4. Let me see if I can highlight that so you can see. So first term. And then it's going to be R, so times R, which is -2. If it's negative, you need to put that in parentheses, okay? Because we're saying that R is -2. If you don't put the negative in with the parentheses, then when you do your exponent, it's going to mess it up. All right, so it's going to be to the n-1. So if you want to, even for the positive ones, to put in the parentheses like this, feel free to do that. But if you do that, you don't technically need this dot. That's just if you don't have a parentheses. All right, then, so there, oh, shoot. Did you see what I forgot? Darn it. You're like, what? What did you forget? G sub n. Gotta have a formula. Can't have a formula without an equal sign. So recursive, that's going to be G sub n is equal to the previous term times by R, which is -2. So you could either go like this or put parentheses and -2. Up to you. We don't have an exponent, so we don't have to put parentheses there. And then, but always, if you want to be safe, just put parentheses, right? And then it says we do want to find G sub 10. So we want to do G sub 10. And I'm going to use the explicit formula here. So I'm going to put, oops, I already have G sub 10. So this is going to be 4 times -2 to the, remember if it's 10, 10 minus 1, 9 to 9. And then, so in your calculators, you would do this. So you go 4, and then in parentheses, -2. And Desmos, the negative is the same thing as the minus. It's one less thing to worry about, right? And then to the 9th power, just like that. If you're doing it on your iPhone, and then you go like this, so you go parentheses, oh, and if you forget the order of operations, and you'd be like, oh, 4 times -2 to the 9th power. Oop, apparently I can't even do that. Where's my delete? Come on. And then you, oh, you get a -8, right? And you take that -8, because it in the iPhone, it doesn't write it out for you. So to the 9th power, then you would get, see how this number is huge? And you're like, wait, that doesn't make it. That's a really big number, right? Because you're doing multiplication first, and you're multiplying, you're doing the exponent for -8 as opposed to a -2. Okay, so that's why you really need to make sure that if you have an iPhone or if you have a calculator that does not type it out for you, you really need to remember the order of operations, right? So you need to do the -2 to the 9th power. So -2 to the 9th power, right? So you got -512, and then you multiply that with 4, right? Do you see how it gives you the same answer? So it's -2048. So this is going to be G10 is going to be -2048. There we go. Oh, and what are the next 3 terms? It's going to be, so this is going to be positive, positive 64, then negative 128, then positive 256, right? Because my positive and negatives, they rotate. All right. Same thing with this. I would pause here and then see if you can figure this out. So it looks like it's times 4. Yep, times 4 all the way across. So R is multiplied by 4. And explicit is going to be, what is it called? Explicit is going to be G sub n is equal to the first term, which is 1, times 4 to the n minus 1. Recursive is going to be G sub n, the previous term, times it by 4. All right, all these answers are below. And if you notice right here, so if you go all the way, scroll all the way down, we are on number 7, I think. See, common ratio, R is equal to 4. Next three terms. See, this is exactly what we have. Notice here they don't put in the 1, right? Because what is anything times 1? It's whatever that anything is, right? So it's kind of redundant. We don't need it. But any other number, you're going to need that. Like here, you see like how here they have the 4 there. Any other number other than 1. All right, so you can just check it here. Scrolling back up. All right, and I'm not going to go through those other ones again. Just same thing here, because you can always just check the answers. Negative 2 times positive 2, because we want it to be still a negative, right? So if we're just multiplying by 2, right? So same thing again, so R is equal to 2. Our explicit is going to be our G of n, or G sub n. G of n is something else, G sub n. And then we have our negative 2, that's our first term, times by R to the n minus 1. And then our recursive is going to be G sub n is equal to the previous term times it by 2, because that's what we're multiplying by every single time, right? And then you could look up the answers for the other things, right? Now, domain and range, if you're ready for that. Remember, domain talks about the x's, range talks about the y's, right? So if you have something that looks like this, what is the domain and range, right? For x, notice it's not continuous, so we're not going to be using inequalities. This is not a thing, okay? We're just going to literally just state them down. So how low or how far left does it go? Like, oh, it goes from 3, 4, 5, 6, and 7. Those are the only numbers that x can be. Oops, I did this a little bit off. Ignore all those lines. My dear. Right, so this point right here, it matches up with 3. This is going to be 6, and this is going to be 7, right? That's your domain. That's all the numbers that x can be. It can't be anything else because there's no other points. For range, we're looking at the y. So we're looking for how low it's going to go. So we look at the y as like, okay, it goes to from -1 and then +1. And this one's going to be 3, 5, and 7. Oops, that's 7. Notice we're writing them from lowest to greatest, okay? So this is a throwback to Unit 1. And you're going to have to keep on remembering to do this, okay? Because it's not going to go away. This year, when in Algebra 2, it's not going away. Same thing here. Pause, do number 10. Tell me what the domain and range is. Okay, I'm assuming you paused, and then you need to now have your work. All right, and so this is going to be, so for domain, how far left do we go? Well, the furthest left point is this one right here at -6. So we're going to make our bracket and go -6. And then this is going to be -5, -4, -3, -2. So I'm just getting 5, -4, -3, -2. All right, range, how low does it go? And it goes, this is as low as it goes. So it's like, ooh, this looks like it's a half. So it's going to be 1/2, then 1, 2, 4, and 8. And we're just looking at the y's right here. 1, 2, 4, 8. Just like that. So it looks like it's definitely decreasing. Is that geometric, or is it what is it called? Or is it arithmetic? Right? And something to think about. All right. And if we take a look at number 11, Now, if you notice right here, so the domain and range, this is different than what we did before, like right here, because these are those 9 and 10 were discrete. This one is continuous, right? So now this is where we do our inequalities. All right, so here's our domain, here's our range. Remember, the domain is how far left and how far right the graph goes. And well, how far left does it go? See this arrow right? Don't be like, oh, -8. It doesn't work like that. Remember, it's going to be, it has an arrow like this, which means it keeps on going on forever and ever. When you guys go to geometry, you got to remember that, because lines, lines are lines because they go on forever and ever. It doesn't stop. That's why we have arrows. Can you draw a line that goes on forever and ever? No, we can't. So that's what we just draw arrows saying, yeah, and so on and so forth, right? So it goes all the way to the left. So what does it approach? What does it go to? A negative infinity. And then it goes all the way to, well, do you see how it goes up? But it also goes to the right a bit, right? So it's slightly to the right, but it's still to the right, which means if it's even slightly pointing to the right, that means it's going to go forever to the right too. So that's going to be from negative infinity to positive infinity. That's how you would say that. All right, but what about the range? Because the range is a little bit different. The range is the y. How low does it go? And it looks like it kind of caps out right here, right at -3. And it doesn't seem to go any lower than that, because that's because that -3 is what we call the asymptote, which you won't learn. We don't need to know that right now, but it's the line. It gets really, really close to the line, but it's never actually touches the line, but just gets really, really close to -3. So it's going to be from -3, y, all the way to, well, how far up does it go? And notice it definitely does go up, right? And it keeps on going up. So it goes to infinity. If you want to write where you're like, well, isn't that the same thing as y is greater than -3? Yes, you totally write it like this. I would say I would get used to writing like this, because this will help. If you get used to writing like this, it'll help you with your notation in algebra 2. So that might be helpful for you. But if you want to do that, that's totally fine too. Not a big deal. All right, so number 12, same kind of idea. So domain and range, press pause. I'm not going to pause, because what are we going to do is like sitting here and waiting. That's not going to be helpful. So you press pause and try it. Just give your brain a chance, okay? And even if it's wrong, it's fine, because literally nobody else knows. Like, I can't see through that video unless I can. That would be kind of creepy. Okay, so here our domain, remember, is pointing, it's going a little bit left, it's veering left, which means we are going to go forever left. And it's definitely going right for sure, right? Do you see that going right? So it's, again, from negative infinity is x, I almost put y, to positive infinity. Remember, it's like an 8 fell down and broke his crown. Joking, running out. No, I'm just kidding. But that's what the domain, that's what infinity is. It's just basically the 8 fell down. And it just goes on forever. Or if you want to think about a racetrack, you know, you just keep on going and going and going and going. I know some people do that, do this, and they find it very soothing. Like if they're on the phone or talking, and they just like doodle, and they just do this for days. Sometimes I do that. All right, so range. If that wasn't you, then I'm sorry. If you find that weird, that is what it is. So how low does this go? And if you see, again, the asymptote right there is at 1. Like that's as it's not going to go below 1 ever. It's not going to happen. And if you ever do this on Desmos, like put it in an exponential equation in there, and if you zoom in, like you do this and you zoom in, like you'll see it it looks like it's right on top of it, but it's not. It's like barely above it. All right, and so this is going to be 1, which is less than y, which is less than positive infinity, because it goes up forever. All right, this one. So, well, here's the domain, and here's the range. Well, again, points all the way left, points right. All in. Usually this is what it is, right? You'll see something like this. And then range, this one is a little bit more interesting. How low does it go? It goes all the way to -4, right? That's how low it goes. Could it be -4? Oh yeah, it could be -4. It's 1, -4. That's the point, right? So we're going to say less than or equal to, in this case, y, and then this can go to infinity. Remember, you can never actually reach infinity. It's not like something that you can reach. So that's why we have less than instead of less than or equal to, because technically you can't get there. Because if you're there, then you could always go a little bigger, which means you're not there. It's very philosophical. All right, so here domain. Okay, here domain is going to be a little more interesting, guys. So for the domain, how far left does it go? Notice how it stops right here, and you hit a wall, right? So that y-axis is that wall. So which means x is equal to 0. So 0 is less than or equal to, because remember, it can equal to it. It's not an open circle there. And how far right does it go? Forever and ever, right? So then positive infinity. Range is going to be, well, how low does it go? It goes as low as 2. Can it be 2? Oh, yeah. And then how high does it go? Infinity. Do you see how it's going more right than up, but it's still going up, which means it goes to infinity because it still goes up. All right, so that is domain and range. Oh, one more thing I should share with you. What if it's just a straight line like this? Like, what would be the domain and range? We're like, well, how far left does it go? Well, it's slightly veered to the left. So yeah, forever left. So this one would be, a domain would be negative infinity. This is like a bonus for those people who watch the video, which is thank you, 2 people. And then, well, how far right does it go? Well, does it, see how it kind of is tilted right? So yeah, that's going to be to positive infinity. Well, what about the range? Well, you're like, well, how low does it go? Well, it has an arrow pointing down, so negative infinity. And how high does it go? Well, it has an arrow pointing up, so positive infinity. So it could be all numbers, all real numbers. Okay, that's all it could be. So this one's like the easiest. All lines have this same characteristic. All lines. The only lines that wouldn't work like that are the ones that are straight up and down, and or straight left and right. So straight vertical or completely horizontal. Those are the only ones that have, like the domain here would be like same as this, from negative infinity to positive infinity, but then the range would be just whatever that number is, because it like doesn't veer from that number. It's just this, whatever that is. All right, and same thing with the the vertical line, right? The domain is very boring. It's just one number, right? But then the range is all real numbers, right? So it'd be negative infinity to positive. But yeah, those would be the only exceptions for that thing. All right, so we're going to determine if this is arithmetic or geometric. So if you remember, arithmetic, we keep on adding the same amount, right? So if we go to the next term, we go up 3. Go to the next term, we go up 3. So we're adding 3 every single time, right? So all arithmetic ones are going to be linear all time. It's not linear because you're not consistently adding the same amount every single time, right? So this is going to be definitely arithmetic. I'm going to go A for arithmetic. And then this one right here, do you see how it starts at 0, then we go from 1 to 4 to 8 or 4? Oh my. Does that make it not? No, but this is. It's just not one that I know. Oh, it should have been 8, but I guess it wouldn't be. But just note, it's not going to get that technical on the test, okay? So if it looks like this would be geometric. All right, exponential, geometric. I don't care which way it is. All right, this one, straight line, going down, which means we're subtracting. We're subtracting 2 every single time. So that's going to be arithmetic. This, going up very quickly, that's multiplying. That's what happens when we multiply. So that's going to be geometric. This guy right here, right? If you notice right here, we go from 1 to 2 to 4 to 8. That was the one that I was trying to do. I guess I did that wrong. But anyways, so this is definitely geometric. Line, arithmetic. Do you see how simple this is? Okay, curve this way or going down, geometric. Line, arithmetic. Done, right? That's the end of the test. So practice some more. Make sure you write those formulas down on a separate sheet of paper so you have that easily accessible to you for later on.